In the previous video, we asked ourselves the question, what should we do if we have a halogen where there's no obvious end that is heavier in terms of its halogen? So let's have a look here at an example. We'll just draw a random haloalkane. Here we are. We've got some chlorine and some fluorine, and here's some bromine as well. Then we'll put just randomly around it some different halogens. Obviously, at the end of every other bond here we would have hydrogens, but we won't fill those in because we want to keep it nice and simple. So I taught you to use what's called my seesaw rule. Now, in other words, you want to work out if one end is heavier than the other in terms of the number of halogens on there. This has 1, 2, 3, 4, 5, 6, so the middle point of this particular carbon chain is right here between these two carbons. So now if you imagine that we're a seesaw here, which end is going to be weightier? Will this end be heavier? Or will this end be heavier? Well, on this end I have 1, 2, 3 halogens. Imagine 3 children sitting on a seesaw. And on this end I've got 1, 2, 3 halogens. 3 children sitting on this end of the seesaw. Neither end is heavier in terms of the number of halogens than the other end. So there's no obvious side that it will swing towards. So I can't simply number the carbon chain from an obvious end. So I have to apply a second rule. Now, the second rule says that the alphabet is important. You're looking to see what total number of prefix numbers you can give, as well as the alphabet ordering the number of halogens. So if I was to number from this end and say that this was carbon number 1, that means 1, 2, 3, 4, 5, 6, I would have a halogen on carbon number 1, 2, 3, 4, 5, and 6. Okay. If I numbered right to left, I would have a halogen on carbon number 1, 2, 3, 4, 5, and 6. So there's no obvious side still, just numbering this side to that side. I could be numbering from this side or that side. So we now have to let the alphabet have some say in the end that I number from in terms of the halogens and their order in the alphabet. Now, bromine, of course, is highest in the alphabet. It's the second letter, A, B for bromine. So I'm going to look now at bromine. If I number from this end, carbon 1, 2, 3, I would say that bromine would be 3, 6. 3 plus 6 equals 9. Okay, that would be the total number given to bromine if I numbered left to right. If I, however, numbered right to left, I would have a bromine on carbon number 1, and I would have a bromine on carbon number 4. 1 plus 4 equals 5. Now, the lower the number, the more favourable it is in terms of deciding what end to number from. So with that information in mind, I could get a lower number by numbering right to left, which is a bit counterintuitive for us, isn't it? If you are from the Western world, we're used to reading left to right, not right to left. But if I make that carbon number 1 and I go 1, 2, 3, 4, 5, 6, I'm going to end up with a numbering system which reflects the alphabet rule and gives priority to the halogen which is higher in the alphabet. So let's have a go at naming it now. I've decided that this is not the heaviest end, but this is the end to number from, which enables bromine to have the lowest possible total prefix numbers. So I'm now going to go for it. I've got a bromine on number 1 and a bromine on number 4. So I've got 1, 4 to tell me where they are. I've got 2 of them, so I need to say di, and they're bromines, so I need to tell myself what they are. I don't say bromine, I say bromo, because bromo has the linking vowel. I've dealt with bromos. Now that I've locked in 1 to 6 right to left, I now need to keep the alphabet law alive. I need to talk about chlorine. Chlorine, by definition, is now on 2, 6, and I've got 2 of them. Dichloro, there's chloro dealt with. And I've also got some fluorine, because I'm numbering right to left, I have to continue. 3, 5, di, because there's 2. Fluoro, because that's fluorine with the linking vowel. Now I have to remind myself how many carbons are there. There's 6, so that's hex. And I want to know if I have double or single bonds. They're all single bonds, so it's an ane. So ane stands for single bonds. So I'm now able to name this rather complex looking haloalkane. I've numbered right to left, not because the seesaw rule told me to, but I had to go beyond that, and the alphabet rule told me that the halogen that came first in the alphabet gets to have the lowest total prefix numbers. 1 plus 4 is 5, rather than numbering here. 3 plus 6 was 9, so I end up with 1, 4, dibromo, 2, 6, dichloro, 3, 5, difluorohexane. That's how you name haloalkanes when neither end is heavier in halogens. But what do you do if you have both ends equal in terms of the number of halogens and you cannot decide to number right to left or left to right in terms of that number rule to give the highest alphabet halogen priority? There's another law, but you'll have to watch my next video.